Hi, this is Roger from Kanka Labs, and today it's about finding replacement 7-segment displays in the case you can't find or get the original ones. Now, I've had this case 2 times in the last month. The first one was this ELV device where I accidentally shorted out 2 of the 5 7-segment displays. And the problem with ELV, they have rebranded 7-segment displays with their own markings, but I was quite sure that I could find the original ones. And I even got a kind of update because, as you can see, these are much brighter than the original ones. I can show you. These are the original ones marked DJ700A, but that's only the ELV marking. These are the replacement parts, which are indistinguishable from the rebranded ELV ones, but they are at least 10 times brighter. The original ones had about that brightness. And the second case is here, where you can see here the third digit has this, the upper segment A is broken. I can remember I already checked before if this was only a broken PCB trace or something like that, but it wasn't. So we'll try to find, with the parametric search, a replacement for this broken one here. And this will be kind of an exercise, what parameters, what you have all to measure and which dimensions you have to take, etc. So let's tear this one down, desolder this one, and see if we can find a replacement. And at the end I will also show you how I find the replacement for these ones here, which was much easier because there was the data sheet is available. So you have all the dimensional information, etc., the pinout, and you only have to look for either an exact equivalent or perhaps even finding the original, which I think I did. So let's open this one and look what's inside, and then desolder the broken 7-segment display. So here's how it looks inside, and I rarely have seen such a bad quality. Look, for example, here at this little daughter board for the external reference input. The daughter board is soldered directly to the BNC jack here, not soldered, not very straight. Everything is secured with hot glue. The IC here is a 74HC04, a hex inverter, and hot glue here over the power switch. Everywhere you can see flux residue. It probably does not come out that bad on camera as it looks in real life. Man, that's really what you expect from ATTEN, which has not the best reputation, and here you can already see why. So let's just take a quick view over the circuit. We have 2 input amplifiers. One, let's take a look, is I think for the high frequency input. Yeah, this one here is the 1 gigahertz input with obviously an integrated pre-divider. And this is the main input. Even the shielding is not a real box, it's just a piece of sheet metal bent around it, but it's open on 2 sides. And what comes then, again, a hex inverter, a 74HC04 as far as I can read it. What else have we got? 3 LSOO quad nans. Here we have the main reference oscillator. It's even a temperature compensated crystal oscillator, and with a little capacitive trimmer here to adjust the reference frequency. And that's at least quite nice to have a temperature compensated oscillator. And then a few other HC ICs. Here we have a 393 and also here. So these are binary counters, so they are probably tapping off the main frequency divided down by in steps of a factor of 2. We have an HC74. This is a dual flip-flop, usually also used as a pre-divider, because you can configure the flip-flop as a divider by 2, and if you daisy chain them you have a divider by 4. I even remember from my home build frequency counter that there an F version, a fast version, or even an advanced CMOS, an AC version, was used to get frequencies above 100 megahertz divided down. And the main counter is simply a microcontroller, an Atmel AT9C51. So it's an AT51 derivative. And so obviously, because this is a software counter, they could have implemented a fully reciprocal counter. I even used this device in a video about how a reciprocal counter works, but as an example for a classical counter, because this gave not the appearance of working like a reciprocal counter, and so even the software implementation of the counting function is not very well designed. The heatsink here, just a piece of sheet metal and the screws secured with some gunk. A look at the soldering here at the rectifier diodes. So I'm not very happy with that. So not much more to say. I think here this is a date code, dates from 2009 by the looks of it. So it's quite a recent device and so badly designed, so no wonder that one of the 7-segment LEDs has broken, probably also of quite low quality. So let's take out the display board. Just let me take another screwdriver. I won't, as usual, do the desoldering not on camera, because this is simply not possible here from my camera setup. And let's see how easily this comes out. Thankfully they've used a connector and not directly soldered the flat cable to the PCB. So one screw is already missing. So we have two other ICs here, HC164, or what is it, and LS145. This could be, from my memory, these are perhaps a shift register and a multiplexer or demultiplexer. So just probably for the control of the 7-segment displays. And this one here is the broken one. So let's take this daughter board out, and I'll be back in a minute, or for you in a second, and hopefully without destroying it, having desoldered the broken display. So here it is, how it came out relatively easily with a combination of first using the vacuum desolder gun and then the last remains of the solder with a little solder wick. And we even have a marking here that says BCS-3191BSR. Try for yourself if you Google this, if you can find anything. So, but now let's take the measures of this thing systematically, and I've already prepared a little sheet with all the measures I could think of that we have to take, and let's do this piece by piece. So these are the measures we have to take. Of course, first we have to find out, is it a common anode or common cathode type? Of course, then the pinout, where the 7 segments A to G are connected to which pins, and some even have 2 decimal points, so we have to note down if it's 1, if it's on the left or on the right side. Of course, the size, the breadth, the height and the depth, the shape of the digit. As you can see here, most today are angled a little bit to the right. The older ones are straight upright. The kind of style, because the individual segments in the early 7-segment types, they were like rectangulars, but the modern ones, you cannot see it here because now it's too small, the segments are shaped a little bit different. And of course the total height of the digit from the uppermost segment A to the lowermost segment D. What's of course quite important is the color, and especially in red and green 7-segment displays there are different types of red and green, so ideally we would have to determine the so-called center wavelength. But I don't have an optical spectrometer here, so we have to rely on a guess which kind of red this one is. And what's also quite difficult to estimate by yourself, modern 7-segment displays sometimes come in different brightnesses corresponding with the center wavelengths. Sometimes, for example, the red is called super red or hyper red and has then a higher efficiency, which means a higher luminescence in candela or millicandela or microcandela. So some of these things are quite difficult to determine, and we can only guess, for example, what the luminescence is and what kind of red this is. But let's start with the simple things. So let's start with the size. The height is 13.1 millimeter. The breadth, is it called breadth or width, is 10.1 millimeter, and the depth is, there's a little, we have to measure really to this kind of little standoff here. So we get 7 millimeters, 7 or 7.1. Let's call this 7 millimeter. Now the digit height is from the upper end of the top segment to the lower end of the lowest segment is, let's round this to 10 millimeters. And of course the decimal point is to the right, it's angled to the right, and we have these modern style segments that are shaped like a trapezoid, as you can clearly see. So next is find out the pinout, and we have 5 pins vertical on each side, and the pin distance is looks like 7.3 millimeter or 3/10 of an inch, and the pin distance will be probably 1/10 of an inch. Yeah, that's rounded 2.5 millimeters, so this will be 1/10 inch pin pitch. Okay, now let's get a battery and a resistor to find out, is it common anode, common cathode, and where are the segments connected. So I got this little LED tester from Osram here, out from the workbench, and it has the nice feature that you can set a constant current from 1 up to 100 milliamps and have even different SMD connectors, etc. But we'll get away with some alligator clips. Now, how do you find the pinout, and if it's common anode or common cathode? You just connect one of the leads to an arbitrary pin and then try to find if you connect the other one with all the other pins in sequence. If, and here the middle segment G is lighting up. So if we would have not found any segment lighting up, you just have to repeat the procedure with the positive pin on your test pin. And if you're very unlucky and we know that your one segment is broken, that you just have connected this to the broken segment, just repeat the whole procedure with the second pin. So here we already have one valid connection, and because here we connected to the middle of the right pin sequence here, we could guess this is the common pin, perhaps. The other possibility would be that here our first test pin is the common connection. Then it would be common cathode, because it's the black alligator clip. If here this pin is the common connection, it would be common anode. So let's guess that this is common anode, so we connect this permanently. And now try if we touch with the ground pin, with the cathode pin, the other pins, if one, yeah, they are lighting up. So we've already verified this is a common anode because the positive pin is common to all. And now we can test one by one the different segments. So on the top left is segment G. By the way, the sequence of the lettering of the segments is simply A is the topmost, and then it goes clockwise, A, B, C, D, E, F, and then what remains is the center segment, and that is G. So the first one was the center one, which is G on pin 1. Then comes F. Then we have nothing, and that is typical that here we have our common anode. Quite often both of the middle pins are common anode, so we can immediately test this. It could also, of course, be the broken segment. You see, here when we connect our common anode to the leftmost, to the middle pin on the left, we also get connection. So both of the center pins are the common anode. And then it goes on with segment A, B, C, D, E. Then comes D. Then comes the decimal point. Then comes C. Now we have again our common anode in the middle. Then comes B, and A should be broken. I would be very surprised if it's working now. No. Of course, if here more than one segment would have been broken, I would have had to desolder a fully working 7-segment display, but because it's only one, we know for sure that the only remaining pin here must be the broken segment A. So we have our pinout, a common anode, and that is the pin layout for the different segments. So that was easy peasy. So here we are at digi-key for a first try to find an equivalent 7-segment display. So let's go to Display, Modules, LED, Character and Numeric. And let us narrow down our search. So number of characters 1. Now we have our size, of course quite often given in inches, but here we also have millimeters. So we're around a height of 0.5 inch. There we are. And let's select all those with 0.5 inch height. The width has to be around 0.4 inch and the depth is 0.276 or 7 millimeters. So these are the ones that remain, that seem to fit. No, in fact there's only this one. 0.5 rounded. Let's see. Width 0.4 and depth 0.276. Let's see if we find something near that still. Okay, this one is also quite near. And do we have anything else? This one here would also fit. No, this one is nearer. This one here would also do it. Remember that you have to press the control button if you're selecting multiple entries. So I think we have found all those that are near 13 millimeter times 10 plus minus 1/10 of a millimeter times 7 millimeter. Let's go back. Yeah, they're all within 1/10 or perhaps 2 or 3/10 of a millimeter. So this one does not fit. Okay, so let's go on and see what else do we have. Digit size. What did we have? 10 millimeters or 0.39 inches. And that is here. These two. Let's include still this one here. We have a 7 segment. We have common anode. The color is red. We still don't know the millicandela rating. But I can show you a little comparison between an old one which will be our next example with the ELV ones, where I connected all the segments, and except for the broken one, here you can see I inject, 100 milliamps total into 6 lighted segments. And you perhaps can see they are not very bright, so they are operating at the moment with something around 15 milliamps per segment. And now let's take, and these had a few millicandelas as luminescence or brightness. Now let's take a modern one with a high efficiency type. And perhaps you can see with the same current, and now all 7 segments plus the decimal point lighting up, so every segment has around 12 milliamps. It's much brighter, and this is in the range of 20 millicandelas. So, and this one comes in the brightness near to our broken one. I've compared them before. So we should leave out the low millicandela range and only take, well, let's say from 5 millicandelas upward up to, yeah, 50 would be sufficient. That's already super bright. We don't know the peak wavelength, but red shall be our initial guess, and let's leave out the package for a moment and see how much we narrowed down our search. There are only 11 results remaining, so let's take a look. And this one even looks close. This one has not the black background, but let's open the datasheet nevertheless and see how well this matches. So the dimensions we already knew, they are relatively near. The pin pitch is okay. And now let's compare the segments, and we have 3 plus 8 is the common anode, and we have exactly the same pinout. So the first one already matches, although let's take a look at the dimensions. They are close enough, I think. The only thing that is a little bit disturbed, and look, do you remember how the lettering was of the original? BCS 3191. We even have similar numbering system. Apparently this SR, which we also found in the original markings, that seems to stand for super red or super bright red. So that's already a hint that we are quite close. The only thing that makes this different is that the background is not black, but more here like a dull gray, like here in this one. And so let's try out the second one. Perhaps this one is even closer. So, from Rome Semiconductor. And how is that? Here we have the common pin here, not in 3 and 8, but the common one is 1 and 6, so this doesn't fit the pinout. Let's see what else we get here. Next one from QT Brightech. So where is the pinout? Where is the pinout? Here we are. And common anode. Let's see. 10 is A, 3 and 8 are, so this one matches the pinout, but we can't see directly because we don't have a picture if it has really the black background. No, they have a gray surface. So this is so we've arrived at 90%. We get one that is really equivalent to this one, except for the black face color, which should be like this one here, but this one didn't have the right pinout. And that would be close enough. Of course, you should also search the other big distributors like Mouser, RS Online, Farnell / Element 14, etc. But I would be quite content to get one of these with the gray face as a replacement. And because, at least if they are in stock, if we now even see what is in stock, there are only 2 remaining. And at digi-key we would have to take this one as the nearest equivalent. So that was 95% successful as search for a replacement. And now, as a final example, let's see how I found the equivalent to these ELV DJ700A, where there was in fact a datasheet available. And by the way, when Googling the original designation of this thing, the BCS 3991 91 BSR, I found one from Oasis Tech, which had the same numbering in the middle, 3191. Ultra red, face color is also again gray, but this seems to be kind of successor of the original one. It has the same pinout, exactly the same dimensions, and so one could also try to get this one, but why should we? We also have this face color as... Okay, here we have one of these original ELV DJ700A made in Thailand, which obviously is a rebranded version. I'll show you again. The luminescence of the old one with one segment and the decimal point broken. As you can see, it's even uneven, the brightness, because some of the other segments also got a little damaged. So we know this is because they used it from the end of the 70s. This is not a very high efficiency 7-segment display. So when we now go to the homepage of ELV, we find this DJ700. Now it's sometimes changed to a green color, and they don't have the old red ones available anymore, but we can download a PDF, and let's see what we get there. And we have a model number from Opto Devices, which is not ELV DJ700A, but looks a bit different. 2411 BUG. The G is certainly for the green one. And there we already have, let's see, gray face, ultra green, that means it's a high efficiency green, white diffuse segment, okay. And here we have all the dimensional information, so we don't have to measure anything. And somewhere must be also, here we have the pinout. So this one has a horizontal pin orientation, and we again have a common anode type. And when we go with this information into the parametric search, so let's remember OS 5211 BUG, or it would be an R for the red one we are searching. And look what I found as an equivalent, a King Bride with SA 5211 and exactly GWA for the green ones and RWA for the normal red ones, HWA for the bright red ones with 900 microcandela, and EWA for a high efficiency red version with between 2200 and 17,000 microcandela. And we have another red one, a super bright red, which is the most efficient one, with a luminescence between 5,600 microcandela or 5.6 millicandela and 21 millicandela. And I've got one of these. You can see them here. SA 5211 SRWA. This must be the original equivalent to this series, because the 5211 that tells nearly everything. And I've gotten the super bright red one, which you already saw. The older ones, the original ones, would probably be this one, but the distributor where I got the super bright ones just didn't have the normal ones. So this is with 90% confidence. This is the original one with the low efficiency, and this is just a high efficiency direct replacement. So if you have the datasheet, you often can guess by comparing the numbering scheme that they use here, who is the original equipment manufacturer, and I'm quite sure that this is in fact a king bright 7-segment LED and that we really have found the original model. So that was also quite successful. As you saw in the beginning, I replaced just all of the 5 7-segment displays just to upgrade them to more efficient ones, because if you desolder 2 or all of the 5, that doesn't make a great difference. So that was it for today, for a little adventure into finding replacement parts for broken LED or 7-segment displays. So thanks for watching. If you liked it, please give it a big thumbs up. You can support me on Patreon and hope to see you next time. Bye from Roger. Bye from Kainka Labs.